Okay, we've got a decent number of people logged on, so we're gonna get started. Welcome everybody. Thanks a lot for attending this presentation with Efficiency Vermont and Mitsubishi. You're attending a presentation through Efficiency Vermont's Efficiency Excellence Network, which we call the EEN. And so if you are not a member of the EEN, I encourage you to join the EEN. We have a different trade group for like architects, builders, HVAC, there's like, I don't know, maybe 15 or 20 different trade groups. So Bryn Oakleaf will put her contact information in the chat, and you can contact Bryn if you're not a member of the EEN. When you join the EEN, you get announcements about trainings and presentations like this. You get access to project support through an engineering consultant at Efficiency Vermont. You get discounts to the Efficiency Vermont conference and other benefits. And then if you are an EEN member, you get credit for attending this if we know that you've attended. And I'll come back to that in a moment. There'll be a survey at the end of this meeting, and I myself oftentimes don't respond to requests for feedback, but I really hope that you do take the time to fill out our survey, because we absolutely read every comment and it helps us to put together trainings and presentations that are the most relevant to you and what you'd like to get, how you want Efficiency Vermont to work for you. If you have logged in as Nathan Mascalino, which some people will have because they got a link that was Nathan's link, please go and change your screen name so we can see who you are, and that will help us credit people who are in the EEN and attending, and also just help us know how many people are attending. So the way that you do that is you hover over your picture, and there'll be a little, like 3 little dots that that pop up, and if you click on those 3 dots, there's an option to rename. And then if you put your name in, please put your full name in so we, again, know who you are. Then that'll help everybody know who you are. We did change the session from 60 minutes to 90 minutes. I hope that you all can stay, but Rachel has a lot of ground to cover, so we extended it. And then while Rachel is presenting, please put questions in the chat. We'll be keeping track of the chat. If you really have something burning that you feel like is a clarifying question and you just don't want the presentation to go on without getting an answer, you can raise your hand, and we'll facilitate you asking a question at that point. But otherwise, Bryn is going to collect the questions together and make sure that Rachel has a chance to address them all, if not right in the moment. Okay. Bryn or Nathan, is there anything else that I should just announce right at the beginning?
No, I think we're good to go.
Okay.
Nope, you covered it. Thank you.
Thanks. So I should have introduced myself at the beginning. I'm Lee-Ling Young, and I'm an engineering consultant at Efficiency Vermont. I mostly work on the residential side. Nathan Mascalino, also from Efficiency Vermont, is with us, and he works on the commercial side of things, so we've got you covered here. And I just wanted to take a couple of minutes and let you know what Efficiency Vermont is doing on the global warming potential of refrigerants. Efficiency Vermont has been addressing the climate impact of leaked refrigerants for about 4 years. And our overall effort is to support natural refrigerants that have no or minimal climate impact. And until high global warming potential refrigerants are retired, so in that I would include R410A and all of the common refrigerants that we use now, they all have a high global warming potential, so they're very impactful in terms of climate if those refrigerants are leaked. So until those are retired, our efforts are around keeping refrigerants in the pipe as best as we and you can do. So we're looking to a future with natural refrigerants, but in the short term, we really want to help you develop skills and designs that keep the refrigerants in the pipe. So it's sort of a three-part initiative at this point, although I think it will grow. Efficiency Vermont does support design that minimizes the opportunity for leaks. So that would include package systems where you don't have to make any refrigerant connections on site at all. Systems with few connections. So for instance, like a one-to-one heat pump versus an elaborate system that might have hundreds or thousands of refrigerant connections throughout a big building. Or hydronic distribution, which would be like very few refrigerant connections, but then the distribution of heating and cooling would be water connections throughout the building. So those are some examples of design that minimize the opportunity for leaks. Our first initiative for this like refrigerant impact reduction was a leak repair program that we had with grocery stores and other refrigeration applications. And it was a really successful program. It's an ongoing program, but there still are many grocery stores that don't participate with us. So there's a lot of work more to do there, but in the places where we have been able to do a leak repair program, it's been very successful. And then currently we're developing the leak tight installation program, which is for residential HVAC. And the sort of headline there is that it reduces callbacks and improves productivity, which I know would be appealing really to any HVAC contractor at this point, improves productivity. So we'll have a training this fall through the EEN, and we have a tool giveaway. Like we're giving away a couple, three actually, really valuable refrigerant toolkits that will include tools that can be used for Heat2O refrigerants. So keep your eye out for that, and I really hope to have a lot of folks tuning into that. And then back to the product that we're here to talk about today, the Heat2O heat pump water heater really checks two of these boxes about climate impact. One is that it's a package system. There's no refrigerant connections to be made on site, and it's a natural refrigerant. So the climate impact is actually, it has a global warming potential of 1, which I think maybe Rachel is going to address. So I'm just wondering more about that. But this presentation right now is part of this big effort that Efficiency Vermont has on reducing the impact of refrigerants. So I'm going to now turn it over to Nathan. He's just going to talk a little bit about water heating distribution in commercial and multifamily settings. And then to Rachel Roy, representative with Mitsubishi, who's going to talk about the product. Nathan.
Great, thanks, Li-Ling. Yeah, as mentioned, I'm with Efficiency Vermont. I work mostly on the commercial and industrial side, and I'm excited here to be able to be the person who introduces Rachel to talk about this technology. And this is a relatively new technology for our geographic area. It opens the doors for a lot of options that we've not had in the past. Rachel certainly will get into that. I want to let everyone know that at Efficiency Vermont, we're trying to stay at the forefront of this technology. We're doing some testing. We're working with some early adopters, and certainly if this is a technology that you're interested in, don't hesitate to reach out on the commercial side. Certainly feel free to give me a call, and we're happy to share any information that we have or know, or put you in contact with any of the industry experts. And I think with that, I'm really excited to hand this over to Rachel. Thanks so much for being here. We very much appreciate it, and look forward to the slide deck.
Thank you. Thank you so much, Nathan and Li-Ling and Bree, everybody at Efficiency Vermont. I really appreciate your time today. And I certainly appreciate everybody's time out of their day to take a look at a new product offering from Mitsubishi Electric. It's quite exciting. Just a little background on me. I've worked for Mitsubishi Electric for about 5 years. And before that, I worked as a design engineer in Maine. So I've worked with low ambient temperature products in the past, and I serve as a commercial territory manager. I serve Maine, New Hampshire, and Vermont. So if you need any assistance, you can certainly reach out to Efficiency Vermont, or you can also reach out to me, and they have my contact info too if you go through Efficiency Vermont. So what I'll be speaking about today is the QAHV, also known as the Heat2O. And our agenda today, I'm going to do an overview over the product itself. Mitsubishi also does have a package with this product, as Li-Ling mentioned. So I'll talk about what we provide as a part of that packaged unit in alongside of the outdoor unit that I'll be speaking of. We have a heat exchanger that is designed to fit into this system. Tanks, we've got circulator pumps as well. Expansion tanks, and some mixing valves, recirculation pump. I'll talk about the control strategy for this product and some different options to you as you're designing it. And I'll also go over some sizing as you're going over this product and you want to fit it into your project. We have some tools for sizing it. And I'll also go over some project examples. I've got a project that I've been working on that has been in the process for the past couple months and should be installed by the end of summer. And then we'll talk about some application and configuration, some guidelines, some piping limitations, just so that you are aware of those as you're doing your project, and looking at elevation restrictions, for instance. And then I'll go over some cold climate provisions that we have, and some at the end I'll go over some future items that will be paired with this product, and some future hopes as the projects go along. So the Heat2O is a domestic hot water heater. It utilizes carbon dioxide as the refrigerant. That does have a high efficiency. The coefficient of performance in this product is up to 4.52, and the high temp hot water that it can put out is 176. That is a limitation based on a UL listing. It can actually perform at a higher temperature, but because it's a domestic water heater, we are limited to 176 degrees. It also has low outdoor temperature ratings, so it will operate down to -13 with capacity ratings, and will continue to operate down to -35. We just do not have testing for those outputs at that temperature. It provides 100% heating capacity at 36 and 50% heating capacity at -13. So I'll go over what that means to the sizing side of things as we go along. I will say the refrigerant is contained to the outdoor unit. The contractor does not have to connect to that high pressure CO2, but we are very excited that it's utilizing a natural refrigerant in this product. This is a variable capacity, so it is technically a variable refrigerant flow system. The outdoor unit, it appears to look like one of our regular VRF units. It has a slightly larger footprint, but the design rating is 136 MBH. And we have some other options as far as the output. As you can see here, that is something that can be changed based on outside temperature and the needs of the system. You can adjust it based on power needs at the time. If you wanted to cut back or produce more during off-peak power, that's a capability with this product. At this time in our climate, we recommend very strongly that you stick to the 136, and that has a lot to do with our winter operation. You can pipe up to 16 of these in parallel. Right now, our Diamond System Builder selection program is limiting us to 6 tanks, so that's kind of the limiting factor. I typically see up to 6 of these done in parallel right now. I have not encountered a project yet where I needed 16, but you know, I don't want to totally cross that out at this point. So the maximum system size is over 2 million MBH or BTUs per hour. Typical max is 4 to 6, as I mentioned before, and we can reduce recirculation losses by actually having several separate systems that are serving a single building if you do have a lot of hot water needs. So this is a break apart view of that outdoor unit. And I think some of the important things to look at here is this gas cooler heat exchanger. This is the refrigerant to water heat exchanger that's in the outdoor unit. And this is what allows our refrigerant to be a contained part of this unit. So the contractor does not need to have any connection to refrigerant piping. That means that they don't need to have a special refrigerant license because CO2 does operate at a much higher pressure than the standard refrigerants currently being used. And you can see there is a water flow sensor in that unit, and there is also a variable speed pump located in that outdoor unit. And this is a single pass water heater. So as the temperature need rises, this pump will actually slow down to allow for greater heat exchange of that water. So that is how we get that higher output of temperature. We reduce the flow. So this is a relatively low flow product, and that means that we need more storage. And I'll get to that in a little bit here. So some of the benefits of CO2 is it is a more environmentally friendly refrigerant. It has a global warming potential of only 1 and an ozone depletion potential of 0. It's non-flammable, it's non-toxic. It has a high pressure to temperature refrigerant, which is part of what allows us to get that higher temperature even at low outdoor temperatures. It has great low ambient performance, and it is very efficient. This gets a little bit into the weeds with the cycle here, but what we are showing is this is one of our regular refrigerant VRF type cycles. You can see that the condensation occurs at the top of this in a regular refrigerant cycle. So we basically put the critical point below the gas cooling part of this cycle, which allows us to get higher temperatures out of the cycle. And it allows that refrigerant remains in the vapor state, which allows for greater heat transfer and better capacity. This is a detail of that refrigerant to water heat exchanger that allows more surface area between the water and the refrigerant, just expanding our efficiency with this product. This is a patented design. It's also increases the amount of turbulence in the water side that again allows for better heat transfer. So because of the relatively small openings in this heat transfer unit, we do need to have another heat exchanger on the inside. We also use flash injection technology in this product, which is pretty typical of all our VRF equipment. Basically, what it allows is it allows us to cool off the compressor as it needs to speed up for lower outdoor ambient temperature. So as the compressor speeds up, it actually will start to heat up, and this flash injection allows us to cool off that compressor and allows that compressor to continue to run at a high rate of speed without overheating. So this is how we get our high capacity, high output at lower outside temperatures. So this is a typical schematic with a single outdoor unit. You can see here, this got water piping that comes in from the outside, and then we have a heat exchanger when you get to the inside. And this protects that other heat exchanger that's in the outdoor unit. So this is a closed loop on the outdoor water side, and it's more of an open loop once you get to beyond that secondary heat exchanger. So this relies heavily on tank storage. We supply the tanks, and this all fits into our design software. So as you're going along and you're seeing what loads you need, we will assist on tank sizing and how many tanks you'll need with our design software. But this is a nice sort of overview of the whole system. And you can see this is the primary side, secondary side with storage. And then we do have a recirculation and swing tank side, and I'll get into that in more detail in a little bit. So the temperature control of this product, we have 3 different methods. One is a local control, where basically the building manager or the owner decides when they'd like to heat water. So they kind of turn it on and off locally. They have their own schedule that they've developed, and it works for them, basically. That's sort of a system where you don't need a lot of, maybe they're saving a little bit of money on the control side of things, and they prefer a more hands-on sort of operation. Not necessarily recommended unless it's a very in tune kind of building where they have a good finger on the pulse of how it's being used. But I think more what I see is that 3 sensor control just below it, where we've got 3 sensors in one of the storage tanks. It's basically the storage tank that has the most stratification, and that engages the outdoor unit and all the pumps. We also have a 6 sensor control method where 2 of the tanks have 3 sensors each. And this gives you a little bit more precise control of the whole system. Basically, as soon as the tank that's less stratified starts to see a drop, it could engage the secondary pump, and then once the first tank starts to see a drop in temperature, then that would engage the primary pump and the outdoor unit as well. So this gets you, if you're really on the edge of wanting a more precise look at the system, that probably the 6 sensor control is the way you'd like to go. And this is a schematic view of each of the different control scenarios. you, for that local control, you're using the input from the outdoor unit, the hot water supply system. You can configure it right on site, which is a nice advantage. Basically, it allows you to just kind of get it going, see how it runs for your building. And then you could add the 3 levels of control later, or the 3 controllers in the tank later. And this is that 3 sensor control. This shows that tank with the stratification. And the nice part about this is it isn't 6 controls, so you're saving a little bit of money on the control side of things, but you're still getting a good reading of what's happening with your system. And then the 6 sensor control, obviously you'd only really use this if you had at least 2 tanks. And again, this gets you a lot more precise control methods. And if you do have multiple tanks, it gives you a better snapshot of what's happening in your system at any moment. So this is a nice overview of what we provide versus what would be provided by a third party. Basically, we provide the more unusual things. Typically, expansion tanks, you can find those at any plumbing supply store. But things like the outdoor unit, obviously, we provide that. But the heat exchanger that's matched to that outdoor unit, we provide the flow switches and the pumps on this primary and secondary side. The building plumbing side of things, that pump would be provided by third party, because that can be sized much more differently than these first 2 primary and secondary sides of the system. We do provide a swing tank, and that swing tank size is based on what kind of hot water recirculation loop you're looking at. And then we do provide the storage tanks, and of course the controls as well. Now we get these products that are a part of our system. They are sourced from high quality manufacturers. We use Grundfos pumps. We've got a SWEP heat exchanger. We've got a flow metering device. And then we get the tanks from, I can't remember where we get them from right now, from a very reputable tank manufacturer. And these are insulated tanks as well. So here's the 3 primary storage tank sizes that we have are 175, 285, and 500 gallons. They use a low velocity sparging pipe that allows for a low velocity inlet into that tank to allow for maximum stratification, which is what we're aiming for. We can have multiple tanks in a single system. And then we've got a couple swing tank sizes, 150 gallons that has a 45 kilowatt heater, and then 200 gallons that has a 54 kilowatt heater. These heaters are there to reheat the losses from the hot water recirculation from the building back to that tank, so that that's not going back out to the QAHV for reheat. And we have some future items that we'll be adding to this to kind of reduce that impact of the electricity for the swing tank. So I'll talk about that as we get further along. So the primary storage tank design, we do have three sizes, that 175, 285, and 500 gallons. And we've got top and bottom outlets. They each have that sparge fitting to allow for a low velocity transfer of water. Basically, we want the hottest water to be at the top of these, and we'll take that off the top. And if you have another tank, that tank will be a more uniform temperature. This is an example of more detailed explanation of that sparging pipe. It reduces the turbulence. Basically, we're hoping that the tank stratification is as much as possible. We've got a main cold water inlet coming into the side, the QAHV water that's headed out to that heat exchanger. We want it to be very cold. That gets us the best efficiency for the QAHV. We're not trying to preheat any water going to that outdoor unit. That will only drop the efficiency of that unit. And then we're taking flow to either the system itself or to another tank off the top. And that secondary tank would be a more uniform temperature. This is our secondary heat exchanger. It's made by SWEP, and it is it's sized for our outdoor units. It's made to go along with this system, and it just allows greater protection of the heat exchanger in the outdoor unit. It is a 2-pass heat exchanger, so it maximizes the efficiency of that exchange between the outdoor unit loop and the indoor unit loop. So the secondary circulator is a Magna 3. It is an ECM, and this is a variable speed pump. It will adjust its speed as needed, depending on what the need is for that hot water heating and what the tanks need. We also have flow meters that's giving us the accuracy of the control for the control system and the pumps. These are our thermistors, some other accessories that we do provide with our system. This is all sized and will be included with all the projects. This is the control panel for the Heat2O. This allows for backnet connectivity, so it can connect into building management system. It does right now have some load shifting and some demand response control capability. You can also monitor third-party devices, so you can see what's going on in the rest of the system. And it is pretty easy to set up. It comes with an install wizard, to make it easier for the installing contractor. And you need 1 panel per domestic water system. So for as long as the system is tied together, it doesn't matter how many outdoor units you have. If it's one system, you need just 1 panel for that system. And this is how the user interface looks. It does have a web-based graphical user interface. You can have remote status and error reporting with it. You can scale it up or down for the building size. And you can also include input from other buildings. The Recirc Pump option, we do offer these if you would like to have us provide the Recirc Pump. Right now, it's not an automatically included product. but we can certainly size one for your project if you require that. So the control strategy review, again, this is a basic layout with a single outdoor unit and 2 storage tanks and a swing tank. The control temperature outlet of the QHV in primary control mode is done at, we've got a flow meter, and the QHV control box has connection to each part of the system as far as what the pump is doing and what the flow is doing. So when you get the outlet temperature where it needs to be higher, the QHV will turn on and that internal pump inside the outdoor unit runs. As long as the flow is at a certain speed, they will start the secondary circulator, which is on the other side of the heat exchanger. And that secondary circulator sees the storage temperature set point, and then it will speed up or slow down to align with what the QHV internal pump is doing to obtain the leaving water temperature serving the tanks. So the main monitoring points, we have a Procon, which is basically, it's a backnet gateway that feeds the information of the system to the control panel. We're keeping track of the primary side flow and GPM. The Magna 3 is the circulator pump on the secondary side. So that's monitoring cold water return temp, hot water outlet temp to the tanks, secondary flow, gallons per minute, pump input power, and BTUs that are being provided. And we also can monitor the power, input power for the COP calculation of the Heat2O. And we can provide a full system COP coefficient of performance and graphically display it on that control panel. So it's a nice control product that allows you to kind of keep track of how the Heat2O is operating. I think I mentioned earlier, you can also keep track of electricity used. And I think with third-party controls, you could probably do some load shifting as required. This kind of a system definitely dovetails in with load sharing and or load shifting, I should say. You could be operating the QHV at night when the utility rates are lower. You could work with the utility companies to develop a schedule that works with your building and to operate the system at the best times that you can. So now I'm going to get into how we're sizing this product and some of the methods we use. We really do rely on designers. We're not in the business of telling you what the size of a product should be, but we can take that information from you and enter it into a product called the EcoSizer, and that is a online sizing tool. It's something that you can use and then send us the information that you get from that. But basically, it's a relatively easy way to size a system. The inputs are simple, and you get very quick results from it. And basically, you enter in what they're asking for in EcoSizer, And once you get the output, we enter that into our Diamond System Builder, and that will get us the sort of the initial schematic, how many outdoor units you need and how many indoor tanks that you need too. So the website for the standard multifamily tool, which is kind of the basic sizing, is very much based on how many people, how many apartments. If you need a more custom application, for instance, if you have a restaurant and you have a commercial laundry load, they do have custom loads available. Basically, we use curves developed by ASHRAE to get the peak loads that you could expect from a certain size commercial, either laundry or dishwasher type of application. And so we can then enter that into EcoSizer. If it's something like a hotel that has commercial laundry in it, then we would do a combined custom application where we're looking at hotel peak loads based on number of beds, and also include sort of an overlay of the commercial laundry on top of that. So we do have a method, and I think a lot of plumbing designers, plumbing engineers use this method themselves. It's been a really long time since I did any plumbing design, so I'm not going to touch that, but I'm very happy to assist people in directing them where to get the information that they need to come up with a complete design. And EcoSizer is a really good way of doing that. So we do have Excel tools. We've got ASHRAE load profiles with a single load shape, and combine those load shapes so you can get some peak output, peak hour extrapolation options, basically. And with EcoSizer, you can also look at the energy savings by using the Heat2O. So the walkthrough of using a typical sizing for EcoSizer, typically what I've been seeing has been multifamily apartments. So you've got 93 apartments, and then we look at the ASHRAE market rate occupancy. It says 187.4 people could be expected in such an apartment building. Daily hot water usage, we're saying 30 gallons per day per person. This could be on the high side, but that's often what ASHRAE targets for apartments. So it's giving us a total hot water, and then the recirculation loop expected losses also. So as you're entering the information, you'll see this chart that has a sliding scale underneath it, and you can shift this based on whether you want more outdoor unit capacity or more storage. So you can slide this one way or the other to maximize either outdoor units if you have more outdoor space and less storage space, or if you'd like to rely more heavily on storage, then you can shift it in the other direction so that you have greater storage and less outdoor units. So this is a nice balance and some bit of control you can have over your system as you're designing it. So basically you're kind of in the driver's seat here. But don't forget, this is a slow GPM type of system. It's kind of similar to, maybe an older thermal solar type of domestic hot water production. You're relying heavily on storage. You need you need a certain amount of storage to have recovery in this system. So if you wanted to eliminate or minimize some of the first cost, you'd move the slider to the right for more storage, because the storage tanks cost less than the Heat2O unit does. Another thing to look at while you're doing your sizing is the compressor runtime. We actually want the Heat2O to be operating a lot during the day, 16 to 24 hours a day. It is made for continuously operating. It is a VRF type of unit, but we actually use the variable speed compressor as a soft start. So once it gets up to the speed that it wants to be at, it will stay at that speed most of the time. And it's very comfortable operating there. We do not want this unit to run for short bursts of time. It is made to operate most efficiently the longer it runs. So once we have output from the EcoSizer software, then we will enter that into our Diamond System Builder. And this is the project properties sort of window that we have for Diamond System Builder. You can set your outside air temperatures based on location, which I typically use that, but you can also hit this manual button and enter in whichever kinds of temperatures you want. And you might want to do that if you expect a very low temperature, for example. As I mentioned previously, this has capacity ratings to -13. It will continue to operate to -35, but anything that you enter below -13, it will only be able to give you capacities for -13 because we don't have testing below that. So even if it says, you know, a certain capacity below -13, it is actually giving you the capacity at -13, and it will give you a little warning to the side as you go along. It will tell you in Diamond System Builder that it's only has capacity ratings to -13. So you've got an output from EcoSizer, then you will enter in the required heating capacity, and this will dictate how many outdoor units you need. You are entering the entering water temperature that you want, and then the storage temperature as well. And you enter in the required tank volume that you're looking for. So this is taken from the previous example. You can have it compute the optimal tanks for you with this button, or you can dictate what size tanks you want to have. Once you've completed that, you will have an image like this. It will tell you how many outdoor units and how many tanks, and it will get you a pretty decent schematic right away that you can put on your drawings. So a custom walkthrough, sort of a nursing home with 100 beds, 50 degrees, entering water temperature, 125 supply water to the faucets, 150 storage temp, swing tank design, and they are expecting a Recirc 20 GPM, and they want, and that will be returning to the swing tank at 110 degrees. This is custom, so you can see the previous slide. This is that ASHRAE curve that we're using. And then an eco sizer, we're using custom load. So we're kind of entering everything in based on that load profile. Actually, you're telling eco sizer, this is the curve we're using. And that gives you an output, and then you enter it in to DSB, that output that you got from eco sizer. And then it will spit out the design for you. This is an example project that I worked on recently. It's the Portland Emergency Homeless Shelter that will be going in Portland, Maine. They've just purchased the products, and I expect them to have it installed probably in the fall. So this was, they had a number of beds and showers. They also had commercial dish and clothing washers. I can't use the standard eco sizer, so I'm going to use customized sizing. I use the ASHRAE load curves for hotels, adhering to time constraints for the occupants, because they had specific times when they are allowed to shower. I combine the loads into eco sizer, use that customized sizing, and then I check the totals. I entered the outputs into Diamond System Builder and check the outputs. All along this phase, I'm working very closely with the engineer. We're not stamping anything. We only provide assistance on the design side. And then I worked with our control solutions to develop customized equipment control layouts for submittal package. This is the sort of the motel curve that I used. And this is commercial laundry and food service load curve that I used. And then this is that combined peak load curves. That was entered into eco sizer. I had a customized output, tank volume 500.85 gallons, gave me a swing tank volume, gave me the heating capacity that's required, 77,000 BTUs per hour. And I entered that into Diamond System Builder. I used Portland, Maine as the location. And then I manually entered in the tank volume, the heating capacity. And then this is the submittal equipment layout based on that design. And this was done by our controls department. That gives a really nice submittal package when you're ready to move on in that phase of the project. So some applications and limitations. As I mentioned before, the outlet side of the QAHV is the maximum temperature output from that is 176 currently. That could go higher, but we are limited by the ratings of the equipment as far as the standards and the UL listing. The secondary side control, you're allowed to store water up to 158 degrees. So that's a couple limiting factors, but that's well within regular design guidelines for plumbing systems. The outdoor unit and the indoor tanks can be located at a distance from each other, but we don't want that distance to be too far because of the limitation of the primary and the secondary pumps. Right now, those are only come in one size, and that's on our side of things, that this is been released. It's been limited release so far. So we don't have a lot of options for different, switching out different pumps yet. So we're stuck with the head that pump comes with. So right now we want everything to be in proximity to each other. And if you've got a case or a scenario where you've got hot water tanks at a different elevation, we would want to look at that. And also you have to keep in mind, using pressure reducing valves. If you have high city water pressure, that's pretty standard in plumbing design anyway. But we just want you to keep that in mind as you're doing your design. So some primary side pumping limitations, we certainly have. We are limited on that primary pump. It's a relatively small pump and it doesn't have a lot of capacity to push water up to a very high high vertical distance. And then we've got a certain amount of water volume. We have a required water volume that we need to adhere to. Basically, some of these, or a lot of these restrictions, are based on that we don't have additional options for different size products in the entire system yet. We are working on that, but it's something to keep in mind in your preliminary design, and we will certainly assist with that side of things. So the impact of elevation, perhaps it makes sense to, if you have a high-rise building, to locate systems at different heights, try to get the outdoor units along the same height as the indoor tanks. You're allowed an elevation max of between 10 to 12 stories between the outdoor unit and the indoor tanks. So definitely keep that in mind during your design. Keep the QHV, the heat exchanger, and the tanks close together as much as you can. So basically that limit is 10 to 12 stories. And that depends on if the outdoor unit is above or below the tanks. Better to keep the piping elevation and lengths on the secondary side if possible, so that the outdoor unit and the heat exchanger are at the same elevation. Then, because that secondary pump has more capacity to pump to higher elevations, the tanks can be at a different elevation. Some cold climate provisions. We do have antifreeze mode options. Basically, when the outside temperature gets colder and it's not, the outdoor unit isn't calling for making hot water, it will engage that primary pump and it will just recirculate to keep everything from freezing. We do recommend right now that you have heat trace on those pipes. As you can see, that we have water pipes going from the outdoor unit to inside. Currently, we do not have clearance to use glycol in those pipes, but we should be cleared to use it in the fall. So we're in testing right now, again, because this was limited release. We're still working out some things, but the project in Portland, we are expecting to be able to have glycol in that system by the time they're ready to install it. We will also look at mounting these outdoor units inside to help with the freezing issue, but make sure that those pipes are insulated well, and right now we're looking at adding heat trace to them, and putting that on an emergency backup, that heat trace on emergency backup batteries. So some future things or things that we have in progress, we're looking at a double wall heat exchanger that would allow for glycol and inhibitors on that primary side, as I mentioned before. We're looking at adding option for a 750 gallon and 1,000 gallon storage tanks, so that we can have up to 16 Heat2Os per system. We'd like to allow 3 kilowatt options for the swing tanks, and add another swing tank size option. We will be developing snow guards and hoods for this product, similar to our VRF units. And we also will be offering a 460 volt 3-phase Heat2O unit, again, similar to our regular VRF options. And we're going to update Diamond System Builder to add project specific drawings, so that we're giving you better drawings as you're developing your own drawing set. So in the future, we actually hope to replace that secondary swing tank with what we're calling now the CAHV. The CAHV is a multi-pass water heating product that allows for higher flow, and can be used to update or upgrade smaller delta T's, basically. So that the QAHV is a high delta T, low flow. The CAHV will be high flow, lower delta T, basically. So it could take the place of a swing tank. This product could also be used as a hydronic heater, or providing hydronic heat, so that you'd have water piping in the building rather than refrigerant piping. So this is another Mitsubishi sort of direction of getting refrigerant out of buildings and using less refrigerant. And of course, we're in the process of moving towards more environmentally friendly refrigerants, as has been directed. So we have different irons in the fire, I should say, on how that's going to take place for us. We're definitely more comfortable with having water piping in buildings than some of the upcoming refrigerants that are being looked at as the replacement for the current refrigerants. But that's still in the future. Mitsubishi does continue to be on the cutting edge and trying to provide what is most wanted and is the most environmentally friendly product that we can offer. This is an image of our training facility. So if there's anybody on here that's interested in getting further training, we have training for engineers and designers. We also offer more in-depth training for installers. We do have classes on installation for the Heat2O. We also have a much more in-depth training for designers for the Heat2O. So we do have a lot of options for the different areas of technology. So if you're interested in any additional training, please contact me. I can get you set up with our training manager, and we do offer a lot of services. And it's this facility is located in Southborough, Massachusetts. So it's, this is the Northeast Business Unit spot. It's located relatively close to Boston. And I do go in here to give trainings too. But yeah, we want to let you know that we do offer a lot of support. There are people in this building who are specialty trainers, but we also have our control solution department here. We have our technical applications people here as well. And so we have over 30 people in this business unit to assist with your design needs from the beginning of the project to the end of the project. We do have technical people that can help solve troubleshooting problems at the end of the project as well. And that's all my slides for today. Please let me know if you have any questions. I'll be here. I think we're open until 1:30, I believe.
Thanks so much, Rachel. Yes, we do have some additional time for discussion and questions. I think what might do is have Leland come back on. She did have a question earlier about the display settings, I think. So we'll give her a chance to get her video and microphone off.
Yeah, Rachel, at one point you said that the power monitoring isn't standard, or maybe you were just saying that the graphical display isn't standard.
The graphical display for it isn't standard yet, but I think that's going to be offered as standard as we go along. So I would need to talk to our control solutions people about that. It might be something that I just have to ask them to include it, and they would include it. But right now, I don't think it's included with the control system, so we'd have to add it.
And then I saw when I was reviewing your slide deck that you had a slide on hot water distribution, and it looks like it didn't make it into the final slide deck. Do you want to add any comments about what Mitsubishi sees as the most efficient way to do like a circulating hot water system?
On like the distribution side, as far as it going out to each plumbing fixture?
Yep.
Okay. So that's a sort of can be a tough balancing act for designers, because you want the occupants to be happy. You want them to have hot water relatively quickly. This kind of goes into that swing tank design aspect. So normally you'd have a recirculation loop for the hot water, where you have maybe at the most furthest away plumbing fixture, you'll have a small half-inch line that recirculates back to that swing tank, and it is a loss, which is why we have to have an electric water heater in the swing tank. But the occupancy comfort will be greater because they're waiting less time for that hot water to reach them than they normally would if there wasn't a recirculation loop. So the recirculation loop isn't that efficient, but it makes the occupants happier. So that's something that has to be decided at the time of the design. And usually it's a requirement if it's a hotel or apartment building, that you kind of have to have that, or else you'll get a lot of complaints. But as I mentioned, we're hoping to have something that will take the place of just a straight up electric reheat option for that swing tank. the other aspect of distribution is if you can get the outdoor units and the tanks closest to the largest loads, that always works better. But that can be difficult when if you're limited to where you can have outdoor units located. Typically they go on the roof, and then the tanks are in the basement. So you have some losses between those two products. And it's hard to convince people to give up important real estate in the building. You know, usually you want the top of the building to have the best views, and you don't want to take it up with mechanical space. So there's definitely a lot of aspects that a designer can try to fit in mechanical pieces of equipment, maybe in smaller spaces in the core of a building, that wouldn't affect the real estate value of the project too. So it's a multifaceted approach that needs to occur. But I also, you know, I think the big thing for the QAHV and ensuring that you have the best efficiency is to make sure that the coldest water is going out to that outdoor unit. That will give you the best coefficient of performance for that product.
Great.
I
And
hope that answered your question. I sort of rattled on for a while.
oh, thank you so much. And I want to also invite people to put questions in the chat, raise your hand, we can take you off mute. It's always nice to be conversational when we can with questions. So happy to pull anybody over. 1 second, let me. Greg, yeah, please share your question. Can't hear you just yet.
There were a couple people actually logged in as Greg Montgomery, so I'm not sure if this person that you unmuted knows that you're inviting them to speak. So
They would have been notified.
Oh, okay.
So this is Pat,
Great.
not Greg. I did get the notification, but when you said Greg, I thought, oh, I better not speak up. So hi, Rachel. One of the questions, or the question I have is, in Vermont, our commercial building code doesn't allow domestic hot water heating elements of greater than 7.5 kW.
Mm-hmm.
And so I'm very worried about how we integrate this system with the swing tank into our commercial code, and maybe others have thought about this question too that are here in Vermont, and if there are variances or the like that we've been able to achieve with the state.
Yeah, that's a really good point, and it's nice to have that specific, you know, knowledge to Vermont, which I have encountered before. You know, when we're talking about doing backup heating with VRF systems too. I think in that case, it might be better to try to locate the equipment closer to the plumbing fixtures if possible, so that you can eliminate needing a reheat or doing a recirculation loop, so that you're retaining more of that, more of the temperature for longer. You have less losses in that case, and that would get rid of your need for an electric swing tank. I guess we could also potentially look at, you know, using a tankless water heater that's fuel fired, which I know that's kind of not the direction we're trying to go in, but until we have the CAHV, that's, you know, our options are somewhat limited in that regard.
Thank you.
Mm-hmm.
I also wanted to note that chat is unavailable for me and probably others.
Oh.
Interesting. Thanks for the heads up on that. I will have to look into that later. I guess if the hand raise feature is working, certainly go ahead and do that. I know that's not everyone's preference. So I apologize for the technical challenge there. That is unfortunate, but does explain a couple things. I guess I'll invite Nathan. I do know we have some other Efficiency Vermont VEIC staff on the call. So if there's follow-up questions there that might be pertinent, project considerations, understanding the how to optimize the equipment, et cetera, invite you all to raise your hand and I can unmute you.
Rachel, can you address the supply chain? I understand that that you've rolled out the Heat2O just in some markets. When might we expect it to be available in Vermont?
So it really depends on which distributor is offering it, and currently both Train and Homans can sell this product. So Vermont can receive the Heat2O right now. Obviously, we'd need to look at the low temperature, low ambient accessories and ensure that we've got that all worked out before we're installing things. And that swing tank is a really good point as well. The electric heat issue, you know, we'd have to be very careful about how we're designing that system. But it is available in Vermont. As far as supply chain goes, we've had some issues getting tanks quickly. Basically, any third-party supplied equipment, we've had some delays on. But usually with these projects, the timing is such that it gives us enough time to get everything, all our ducks in a row, to ensure that it's there when it's needed. We are struggling with getting certain pieces of equipment on site, but that is quickly coming to an end as our shipping improves, and we've just opened new warehouses in closer to the Northeast region. So we've tried to accommodate our customers as much as possible, but like a lot of manufacturers right now, we are struggling. We seem to have a good supply of the Heat2O itself, but again, the tanks are taking a longer time, and we're looking at sourcing them from different manufacturers right now.
That's an excellent question. Rachel, are there additional installer trainings that Mitsubishi offers, or like certifications for installers that you provide yourself or in coordination with distributors or suppliers?
Yep. So basically all our higher tech training happens at that Southborough office, and a contractor can get in touch with their distributor to assist them in setting up the trainings. Or if you reach out to me, I can get them in touch with the manager at that facility. Okay. And she can get people signed up also. And we have specialty training for VRF equipment on the install side. We have specialty training for controls. We have specialty training for the Heat2O, and also for split systems, for the multi-split systems. We have a lot of training available for that as well.
Great. And did you have a contact slide?
Nope, I don't, but
Okay. We can
I
certainly
can-
invite people to reach out to us and we
Yeah.
can coordinate with you and for future offerings as well. So
definitely.
absolutely not a problem there. Certainly want to not cut it off too soon, but if there aren't additional questions, we can give folks a couple minutes back to their day. Significant thanks to everyone that joined today. Please complete the survey. Feedback is very helpful. And certainly a major thanks to Rachel for your time and expertise here. We really appreciate it. So hopefully we see you again for some future trainings in the very near future.
Thank you so much for having me. I appreciate it.
Yeah, thank you. Thanks everyone. Have a great afternoon. Bye-bye.
Thanks, Rachel. Bye, everybody.
Bye.